Okay, trig identities again, and these examples are going to help you with section 5.2. There are some basic rules. Work only one side of the equation. Factor or add, use identities, change to sine or cosine, try something. Okay, so here we go with an example. Secant squared theta minus 1 over secant squared equals sine squared. So we're going to work one side. Now usually I want you to work the left side. But if you somehow look at the left and don't like it, you can work the right side, but you can only work one side of these. And it's usually easier to take something that's more complicated and make it simpler so that this is the most complicated side, so this is the side I choose to work with. So my first step is I'm going to replace secant squared theta with something. How about tan squared theta plus 1 minus 1 all over secant squared theta. So I replace secant squared theta with tan squared theta plus 1. Direct substitution using identities. Now I'm going to simplify. The ones are going to cancel out. So now I have tan squared theta over secant squared theta. Now I'm going to rewrite this. Tan squared theta times 1 over secant squared theta. Then I'm going to rewrite tan squared theta as sine squared theta over cosine squared theta times 1 over secant theta is cosine squared theta. So I'll make that cosine squared theta over 1. Oh man, you see what's going to happen here? Cosines are going to cancel out. Final answer, sine squared theta. Can you see that down there? And that's what I was trying to get. Boom, got it done. All right, I'm going to do one more example of this problem a second way. So let's write it again. Secant squared theta minus 1 all over secant squared theta. Suppose I wanted to write this as two separate fractions. I could write it secant squared theta over secant squared theta minus 1 over secant squared theta. I took the top and broke it up and I wrote two separate fractions. What does this become? I hope you noticed it can become 1, and 1 over secant squared theta can be cosine squared theta. Oh, 1 minus cosine squared theta. Sine squared theta. Isn't that what I was trying to get to? Right? Because this started with equals sine squared theta, right? So each time I work one side of the problem to get the other side. Sine squared theta equals sine squared theta. Cool, that's what I was looking for. So my second method ended up being easier. Go figure. Anyway, both solutions are correct, and I think you can do these. I have one more example I'm going to do. So let me clear my board. All right. What if I have this one? So we'll call this example 2. 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha. Well, it's two fractions, right? Let's add and make them be one fraction. That means I need common denominators. Common denominator is both of these, 1 minus sine alpha times 1 plus sine alpha. So on this one, I'm going to multiply 1 plus sine alpha times over 1 plus sine alpha. I'm multiplying the fraction by 1, right? 1 minus sine alpha plus, what am I going to multiply this one by? 1 minus sine alpha over 1 minus sine alpha, which is also 1. 1 minus sine alpha, 1 minus sine alpha times 1 over 1 plus sine alpha. I'm going to put these in parentheses so that they look a little bit better. It's safer to always put these quantities in parentheses because you don't want to be separating parts of them out. Now, when I do this, I can write it now as 1 fraction over, and if I multiply that out, I get 1 minus sine squared alpha. And on the top, I have 1 plus sine alpha times 1, which is 1 plus sine alpha, times this by 1, and I get 1 minus sine alpha. Now I'm going to combine like terms. The 1 and the 1 is going to be a 2, plus sine alpha minus sine alpha. That's going to disappear. So now I have 2 over 1 minus sine squared alpha. Can 1 minus sine squared be replaced by something? Yeah, cosine squared. So I'm going to go up here. So now I'm going to have 2 over cosine squared alpha, which I'm going to write as 2 times 1 over cosine squared alpha. Do you see where I'm going? Oh, I forgot to put what we're headed towards here. 2 secant squared alpha. Sorry about that. 1 over cosine squared is secant squared, so 2 times secant squared alpha. And that's what I was trying to get, 2 secant squared alpha. So remember, you should have an equal sign in both sides of the equation when you start. And basically, I didn't change the second side. I did all these substitutions, and boom, I got the second side. So I got the answer they wanted me to try to get. You can do these. Good luck.